Okay, so let's look at decimals, and I suppose we'll start by looking at place value. Okay, so basically it's looking at place value and I guess how to convert a decimal to a fraction. Okay, so if we have a number like 54.563, that's 54, the whole number, and this decimal part 0.563. Okay, and when it comes to place value, we note that the first place after the decimal point refers to the tenths, the second place refers to hundredths, and the third place to thousandths. And if we were to rewrite 54.563 in terms of tenths, hundredths and thousandths, we'd say that 54.563 is the same as 54 and, which is the decimal point, 5 tenths, 6 hundredths and 3 thousandths. And if we were to add 5 tenths plus 600 plus 3 thousandths as three fractions, then we would get 54 plus 500 plus 60 plus 3 all over 1,000, 1,000 being the lowest common multiple of 10, 100 and 1,000, and that would give us 54 plus 563 thousandths. And if we look at some other decimals here and continue to convert them into fractions, we can see that there's a rule that we apply in that 67.34. What's the rule? We say that's the same as 67 and 34 hundredths. We get the hundredths underneath the line here because we are considering the tenth, the hundredth place. We've 2 digits after the decimal point, so our fraction here will be mindful of the 2 digits or 2 places past the decimal point, so we'll be talking about hundredths. Again, 67.04, there's 1 digit, 2 digits after the decimal point, so we're talking hundredths, so it's 67 and 4 hundredths. In this instance, 67.1, now we've only 1 digit here, so we're going to be talking about tenths, so that's 67 and 1 tenth. We've 3 places after the decimal point here, 3 relevant digits, so that would be 67 and 3 thousandths because we've 3 places after the decimal point here. Here we've only 1 place after the decimal point, so that's simply 6 tenths because 1 place. 2 places here, 0.06, that must be 6 100ths, and here we've 3 places after the decimal point, so that must be 364 1,000ths. And to go the other way, i.e. to convert a fraction to a decimal, well, if we have a fraction like 3 over 4 here, then what we're doing, in fact, mathematically, is we're dividing 3 by 4. So you might recall the division sign like this, but mathematically 3 divided by 4 is the same as 4 into 3.0000. We can just add zeros all along, doesn't really matter. So if we're dividing 4 into 3.00, we move our decimal point up from below, up above, and we say 4 into 3, well that won't go with it, so we get 0. 4 into 30 goes 7 times, and 7 times 4 is equal to 28. We take the 28 from the 30, and that gives us 2, and we bring down our 0, as we do it with long division. We say 4 into 20 goes 5 times, 4 is 20, and 20 minus 20 is 0, so we stop. So the fraction 3 over 4, written as a decimal, is 0.75, and we found that by dividing 4 into 3.0. Let's look at the fraction 1/8. Well, that's the same as 1 divided by 8, which is the same as 8 into 1.0000. So if we bring up our decimal point, first of all, we say 8 into 1, well it won't go, so that's 0.8 into 10 goes once. 1 times 8 is 8. Take 8 from our 10 here and we get 2. Bring down our 0, so with 8 into 20, that goes twice. 2 times 8 is 16, 20 take away 16 is 4. Bring down a 0, 8 into 40 goes 5 times, 5 times 8 is 40, 40 take away 40 is 0, and we stop. And we get our answer as 1 over 8, written as a decimal, is 0.125. Let's look at adding and subtracting decimals. Well, the simple rule here is to keep the decimal points over each other. Okay, so 12.24 plus 6.72, we keep our decimal points in one line, and we simply add 4 and 2 is 6, 2 and 7 is 9, 2 and 6 is 8, and put down your 1. 12.24 plus 6.72 is 18.96. Similarly here, if we have 14.05 minus 1.62, then we keep our decimal points in line, and we say 5 minus 2 is 3. 0 take away 6 you can't do, so we'll borrow 1 from the 4 here, so that becomes 13, and 10 take away 6 is 4. 3 take away 1 is 2, and 1 take away nothing is 1. So 14.05 minus 1.62 is 12.43. Just keep the decimal points underneath each other when you're adding and subtracting decimals. Let's look at multiplying decimals. Let's look at multiplying 14.72 times 1.8. Well, the first thing we need to do is to count the number of digits to the right of each decimal point and to add them. So I have 1, 2 there, and I have 1 there. So the total digits after the decimal points in for both 14.72 and 1.8 adds to 3 places. Okay, 1, 2, 3. So we just make a note of that 3 places, and then we carry on and multiply 1472 times 18 as whole numbers, really. Okay, so 8 2s are 16, carry the 1, 8 7s are 56 and 1 is 57, put down the 7, carry the 5, and 8 4s are 32, plus 5 is 37, carry the 3, and 8 1s are 8 and 3 is 11, put down our 0 here, and we write 1472 there again, 1 by 2, 1 by 7, 1 by 4, 1 by 1. Add them all up, we get 26496, but we have to bear in mind that up here we had 3 decimal places, so from the right hand side of our 26.496 we literally bounce in 3 places, and we put our decimal point between the 6 and the 4 to get our answer as 26.496. So let's just see here what happens with decimals if we're dividing decimals by 10, 100 or 1000. Well, if we're dividing a decimal by 10, the decimal point moves 1 place to the left. And if we're dividing by 100, it moves 2 places to the left, and by 1000 it would move 3 places to the left. Okay? And similarly, I suppose the opposite to that is if we're multiplying a decimal by 10, 100 or 1000, the decimal point would move 1, 2 or 3 places to the right when we multiply by anything to the power of 10. So let's look at dividing a decimal by a whole number. So 12.8 divided by the whole number, that is 2. That's the same as 2 into 12.8, and we can just add a trail of zeros here. We bring up our decimal point, that's the first thing we do, and we say 2 to 12 goes 6, 6 times 2 is 12, 12 times 12 is 0, bring down your 8, 2 into 8 goes 4, 4 times 8 is 8, 8 take away 8 is 0, and we stop at that. So 12.8 divided by 2 is 6.4. Look at this one here, 128.4 divided by 4. 4 goes into 12 3 times. 3 by 4 is 12. 12 take away 12 is 0. Bring down our 8. 4 and 8 goes twice. 2 4s are 8. 8 minus 8 is 0. And we still have our 4 to bring down here. And we say 4 goes into 4 1 times. 1 times 4 is 4. 4 take away 4 0, so we stop at that. So 128.4 divided by 4 is equal to 32.1. So let's look at dividing a whole number by a decimal. So this is slightly different now. So 9, the whole number, divided by the decimal 0.3 is the same as 9 divided by 0.3, and that's the same as 0.3 into 9.0. Now when we try to divide a decimal into a number, we need to clean up the decimal, and we have to make it a whole number. So we need to move the decimal point to the right until we have a whole number at this point in the sum. Okay, so to make 0.3 a whole number, we must move the decimal point one place to the right, and that's what we've actually done here, and that gives us 3. But what we do to the 0.3 on the outside, we must do to the 9.0 on the inside. So we move the decimal point for that one place to the right, and that gives us 90 here. Okay, so we're actually dividing 3 into 90, but mathematically it's the very same thing as dividing 0.3 into 9.0. So 3 into 90, we write our sum here, and we move our decimal point up to its place, and we know that 3 goes into 90 30 times. Well, 3 into 9 goes 3 times, sorry. 3 3s are 9. 90 take 90 with 9 0, bring down our 0, and there's no more division to do. So our answer is 30.00. And again, we're dividing a decimal by a decimal. So here we're dividing 13.2 by 0.15. So we've 0.15 out here. That needs to be a whole number. We need to move the decimal point 2 places, which we do to get 15. And we must do the same to the 13.2. So we must move that 2 places. So that becomes 1320. So now we're looking at 15 into 1320, the very same as 0.15 into 13.2. And we carry on as follows. So 15 into 13 won't go. 15 into 132 goes 8 times. 15 is 120. 132 take away 120 is 12. Bring down the 0. So we have 15 into 120. We know that goes 8 times. 8 times 15 is 120. Take away the 2, we get 0. So our answer is 88.00. And if we look at just rounding decimals here, basically if we're looking to round a decimal to a certain number of decimal places, say 2 decimal places, then if it's 2 decimal places, we look at the third digit or the third place after the decimal point, and we look to see if it's a 0, 1, 2, 3 or 4, in which case we'll do nothing to the value of the second digit, the second decimal place digit. But if the third digit after this place is 5, 6, 7, 8 or 9, then we'll add 1 to the second digit after the decimal place. So for example, to round to 2 decimal places 43.879, we look at the third digit. Is it 0, 1, 2, 3 or 4? No, it's not. It's actually 9, so it's from this group of numbers here. It's a 5, 6, 7, 8 or a 9, so we have to add 1 to the second digit in the second decimal place. So that actually becomes an 8, the 7. So our answer is 43.88. And to round 42.611 to 2 decimal places, we look at the third digit. It's a 1. So that means we do nothing to this digit in the second decimal place. So 42.611 is the same as 42.61 rounded to 2 decimal places. And just a quick mention of rough estimates. So if we're just guesstimating or rough estimating big numbers, we can just sometimes estimate them to the nearest 10. So 82 to the nearest 10 is 80. 80, 0, 80, 81, 82, 83, 84 to the nearest 10 is 80. 85, 86, 87, 88 and 89 would be 90 to the nearest 10. So here 85 to the nearest 10 is 90 because this digit is a 5, 6, 7, 8 or 9. 149 to the nearest 100 is 100. 150 to the nearest 100 or 151 would be 200. And here we go, here's an example. 151 to the nearest 100, sorry, it's a bit missing there, a bit missing there and there, is 200.